Welcome everyone to our professional development. Today we will be looking at a particular maths word problem and going through the explanation, carrying out a plan and finding the solution for this problem. So this problem consists of finding two different answers. We'll be going through how to figure out those two answers and we'll be applying the Polyer's solution to find those two answers. So the question is, on the coast there are three lighthouses. The first light shines for 3 seconds and then is off for 3 seconds. The second light shines for 4 seconds and then is off for 4 seconds, and the third light shines for 5 seconds and then is off for 5 seconds. All three lights have just come on together, so we're trying to determine when is the first time that all three lights will be off, and then the second part of the question asks us when is the next time that all three lights will come on together. So what we are trying to determine for the first part of the question is looking for a certain pattern. So how we will do this is by looking at the key words. So we know for the first part of the section that the first light shines for 3 seconds and then is off for 3 seconds. The second light shines for 4 and then is off for 4, and then the third light shines for 5 and is off for 5. We also know that all the three lights have just come on, so that gives us a good guide for our first part of the question. So now we're going to look at what areas this particular word problem relates to in relation to the Australian curriculum. So the first one is patterns and algebra, and these all relate to Year 3-4 curriculum. In doing this problem, students will describe, continue and create other patterns resulting from performing addition or subtraction. In this case, it will be addition, which is ACMNA060. They'll also collect data, organise them into categories and create displays using lists, tables, picture graphs and simple column graphs, with or without the use of digital technologies, which is ACMSPO69. In this particular case, they will be creating displays using lists or tables, depending on how they would like to do it. We're going to be using a list. And then it also relates to investigating number sequences involving multiples of 3, 4, 6, 7, 8, and 9, and that's ACMNA074. And they're also going to be recalling multiplication facts up to 10 times 10, and using related division facts. In this case, we are only going to be looking at the multiples of 6, 8 and 10 that will come in the second part of the question. They won't be using any multiplication facts in the first part. So, like I said, we've got the first keywords of the problem, which is 3 seconds on, 3 seconds off. The second is 4 seconds on, 4 seconds off, and the third is 5 seconds on and 5 seconds off. So for the first part of the question, I've chosen to use a strategy of writing out all of the lighthouse patterns. I found this very easy to do, and this strategy would work very well, especially with Year 3s and 4s. The mathematical concepts used, especially in this, consist of writing columns and also colour coordinating. That's what I've chosen to do. The second part of this problem, like I said, utilising multiplication facts and students being able to recall them. They will be using their 6, 8 and 10 times tables. They will go quite far into those multiplication facts and recalling them. They can also use skip counting if they're not confident with that. However, to overcome the second part of this question, if students do not feel as confident, they can actually use a calculator, but we'll get to that in the second part. So to figure out when all the three lights are off for the first time, I've used this strategy. So I've written out columns for Lighthouse 1, Lighthouse 2 and Lighthouse 3. As you can see, all of them are on at the same time, so they've all got 1 second in green. 2 seconds in green because they're all on at this point. 3 seconds in green as well. Then we get to the first lighthouse, which is off for 3 seconds, so that is written in red. We continue to go down. Now students can use this strategy and write from 1 to 10 purely, and then figure out afterwards using colours or just recognising the number pattern what number we have discovered now, which is turned off. So by doing this, I've used columns. I've also recognised here that the first line of all three red numbers is 6. So that gives us the answer for the first. So the 6th second is the first time that they will all be off. As I keep going through, I can still see that there is none other time that all three lighthouses will be off at the same time. So I can assume and clearly see that that is the answer. For the second part of the question, we are asked to figure out what is the next time that all all the lighthouses will be on at the same time. So this one is a little bit trickier, and this, like I said, will allow for students to recall multiplication facts or skip counting if they're not as confident. So to get the first part of the answer, I saw the pattern in the first question that they'll all be off on the second part of their number pattern. So the first numbers, however, they're on, the second part they're always off. So by doing this, I decided to double my original numbers, which were 3, 4 and 5. So by doing this, I've used my multiplication facts. 3 times 2 equals 6, so that will be the first number that we'll be using. 4 times 2 equals 8, which will be the second number we'll be using. And 5 times 2 equals 10, which will be the third number. So by doing this, we now have realised we found the number pattern that it's every second time that we're looking for, so that they'll be turning on again. So by doing this, for those 3 numbers, we need to find the lowest common multiple of the double of each number. This, like I said, can be quite tricky to overcome. So by doing this, students may use a calculator or they can use skip counting. So the next section that we've gone on to is just writing all of our multiplication facts, recalling them. I'm going to go through now and show by elimination what would be the lowest common multiple in all 3. By doing this, the process of elimination, we keep going until we found the recognisable number, which is 120. So by doing this, by writing out all of our times tables for each of the doubled number, we find now that the common number between the lowest common multiple of each number is 120. There is no other number in any of these facts that are the same as each other. So now that we know it's 120. So to the end of our solution, the answers are the first time that all the lights will be off, we 6 seconds, which we use sequencing and number patterns to figure out that it was 6 seconds by using columns and recognising that 6 was the only number in red as well for another visual way to see. And the next time that all the lights will be on will be 120 seconds or 2 minutes, and we use that by recalling our multiplication facts. So all of the strategies modelled and used within this number sentence or this word problem are all aligned with Year 3-4 substrands in the curriculum. I hope that you guys understand everything. If you would like any clarification, please let me know and see me after.